Good morning, my dear students. This is Sriram, lecturer in zoology, MSc, APSET qualified. Today, I want to discuss about a very important topic for Neet concern, that is conduction, generation of action potential. Generation and conduction of action potential. Action potential is to be as nerve impulse. Along with the nerve, how action potential get be generated and how it get be conducted. To know about this is very important to us. This is our nerve cell. This is our nerve cell. Inside the nerve cell, there is the fluid called axoplasm. Outside the axoplasm, this is the surrounding of it. Surrounding of it containing the fluid is said to be as a extracellular fluid having ECF outside. This is the membrane which divided the inside axoplasm, outside fluid, that is the extracellular fluid. Here, one remembering point is there. That is, always action potential travels through the membrane, never through the axoplasm. Action potential, remember it, action potential is moving through the membrane, never through the axoplasm. And I am saying action potential is propagated through the nerve fiber, but not through the axoplasm. Question asked like this: action potential propagated through the axoplasm. Statement A. Action potential traveling in the ECF. Statement 3. Axoplasm travels through the membrane. Among these statements, which statement is correct like this I ask? Answer is action potential propagated through the membrane, not through it. Never. Action potentials are not generated to the axoplasm. There is a very important system present in our body, that is a sodium-potassium pumping system, which is related with nerve cell. That pumping is said to be as sodium-potassium pumping system. Sodium-potassium pumping system. It is a unique system. It is a hallmark system useful for the transport of sodium ions out, potassium ions are in. Sodium ions, 3 sodium ions are move out, whereas the 2 potassium ions are moving. Again I am saying there is a very important system which is associated with the nerusal, that is sodium potassium pumping system. It is very very important system to us to maintain the equilibrium of ions inside and outside. Previously, wherever there is a random distribution of or uneven distribution of the ions are there, that uneven ions which are previously disturbed make them even or conduct, that is maintain the equilibrium by sodium potassium pump. What is the use of the sodium potassium pumping system is, the sodium potassium pumping system useful for make them the ions unevenness to even. That is the use. Previously, whatever it may be, the situation is done. There is no balancing of ions inside and outside. It is the system by using of energy. It is for this pumping system, energy is required. It is depending upon the energy system. For that, it is said to be as active process. Sodium potassium pumping system is active process. Sodium potassium pumping system useful for make them uneven ions to make them even in their number. Sodium potassium pumping, sodium ions and potassium ions, it pump always. Sodium ions move out, potassium ions move in. For every 3 sodium ions move out, 2 potassium ions are moving. Then here, this is the ECF. During a normal condition, during a resting condition, on the time, nerusal is said to be as polarized. Nerusal is said to be as polarized. On the time, here, there is no movement of, here inside that axoplasm during resting state, there is the negative charge. There is the negative charge. It is minus 70 MV millivolt in the nerusal concern. Whereas in an ECF, there is a positive charge is seen. Here inside the axoplasm, there is a negativity is there. What are the reasons to make them negative? During polarity state of nerusal is important. Reason one, here more potassium ions are moved than the number of sodium ions are moving. Reason one, more potassium ions move out than the less sodium ions move in. This is the reason one. Reason two, there is no efflux of anions. There is no efflux of anions. Efflux means movement of this to there. Here there is no efflux of ions from. So again I recap. What is the reason? Inside the axoplasm is become negative. Outside the axoplasm is positive. Inside the axoplasm, negativity is caused due to the more efflux of potassium ions. There is a more efflux of potassium ions, and less influx of sodium ions. There is a less influx of sodium ions. That is the reason one. Less influx of sodium ions and more efflux of potassium ions is causing the negativity. Inside the axoplasm, there is a different types of proteins are there, axoplasmic proteins. Along that, they having some sulfate like that, sulfate, carbonate, like that. Anions are present inside. These anions never move out. Remember it. Nerve fiber covering axolemma is the site not able to taking anions to move out. It is allowing sodium ions and potassium ions through it. These ions movement is also highly specific. Sodium ions travel to the sodium specific channels. Potassium ions are traveled through the potassium channels. Never sodium ions are traveled to the potassium channels. Potassium ions are not traveled to the sodium channels. Through that, some channels are present here. They may be the leakage channels, they may be the gated channels. These channels always useful for take sodium ions from out to in, potassium ions are take into out. Observe here, sodium potassium pump is contrast to it. Sodium potassium pump is make them to move out sodium ions, then taking in potassium ions. Here these are the different types of channels present on the membrane. They may be the leakage channels or voltage gate channels. Leakage channels are having sodium leakage channel, potassium leakage channel. There is the voltage gate channels, sodium voltage gate channel, potassium voltage gate channel. Here, these highly specific channels are make them inside negative. Reason one, I already wrote on the blackboard. More potassium ions are moved, less sodium ions are moving. There is no movement of, or there is no diffusion of the substances like anions from axoplasm to out. Question asked like this in Neet. During resting state or during polarity state, inside the axoplasm, what type of charge is there? Negative charge. Outside that, what type of charge is there? Positive charge. During resting state, ions are moved more or potassium ions. Negligible or low amount of ions are moving or sodium ions. Which ions are never diffused through this membrane? Anions. What is the reason inside the axoplasm becomes negative during resting state or polarity state? Reason 1, more effluxivity of potassium ions. Reason 2, anionic movement is not showing here in this condition. No, there is no anionic movement is not seen at all in this fiber concern. Then go for the conduction of action potential, how it is conducted. So here this is a fiber, this is our neruzal, this is the axon hillock, this is our fiber, this is our nerve fiber. Here, you know that already there is the negative charge. There is the negative charge. It is the positive charge. It is the positive charge outside the axoplasm. It is a site A. It is a site A. I divided it is a site B. I divided it site A and site B. He observed during resting state, as said to be as it is at polarity state. At site A and site B are same. Inside that negative charge, outside that positive charge. Their value is minus 70 MV millivolts. Now, here some gated channels are there. That gated channels are called sodium gated channels. That gated channels are open. There is a rapid influx of sodium ions are moving. Due to the rapid influx of sodium ions in this area, charges becomes reversed. Due to the influx of sodium ions, inside previously, this is the previous condition. It is the current condition. When more influx of sodium ions inside, their charges becomes reversed. It becomes positive. It is the A site. Outside, they becomes negative. Site B is as usual. Here negative charge is there. Here positive charge is there. This is the site B. This is the site A. Please observe on the blackboard what I draw the two diagrams. Condition 1 is previous status. Condition 2 is the current status. In previous status, there is a negative inside, there is the positive outside throughout the membrane. It may be the A site or it may be the B site. Now condition becomes differ. It is a current status at which more sodium ions are influx. By the opening of the voltage gate channels, both here observed that there is the two gates are opened, activation gate and inactivation gate. Due to that, rapid influxity of sodium ions are there. Due to the accumulation of more sodium ions, their charges becomes changed. You observed charges becomes reversed. Negative becomes positive. Positive becomes negative. Site A is changed, but site B is not changed. Here, once their charges becomes reversed, action potential is generated or nerve impulse get be generated. In this situation, it is said to be as for depolarity condition. This is said to be as a depolarized condition. Depolarized condition is also said to be as a rising. Here, something get be raised means minus 70 is converted into minus plus 45. Plus 45 millivolts get be changed. Minus 70 MV millivolt to plus 45 millivolts. Means around 125 MV millivolt get be changed here. Whenever the depolarity is observed in a current situation, their value get be changed from minus 70 to plus 45. Means around 125 millivolts get be changed. On that time, action potential get be generated and conducted. There is a beyond that Ncert, there is one principle is there, that is all or none principle. All or none principle. Action potential conducted, or it may not be conducted. If it is conducted, it follows all rule. If it is not conducted, it is followed none rule. Means there is a minimum value is there for conducting the action potential. There is a minus 70 is there now previously. You observed there is the minus 70. These minus 70 minimum converted into minus 55 millivolts. That is that threshold potential. Minimum action potential changing is minus 15 millivolts. That is 15 millivolts get be changed. This is the threshold value. Threshold value is said to be as changing of the value of minus 70 to at least minus 55. Means 15 volts get be changed, then only action potential get be generated. Otherwise, it becomes null. It becomes none. So observe here, there is a, in site A, their charge get be reversed means always here current get be moving like this. Here current get be moving like this. Circuit is formed. On axoplasm, current is moving from B side to A side. In axoplasm, current is moving from site A to site B. Question asked like this. Whenever the depolarity is occurs, current flows in axoplasm from this side to this side, from B side to A side. In axoplasm, that current get be travelled from A side to B side. In outside, that is travelled from B side to A side. Recognize it. Then here, changes observed during the depolarity condition. That change is the depolarity wave is coming here to B, then coming there, they go for C like that. Depolarity is moving forward, repolarity is formed back conditions. Here the wave is moving like this, here depolarity is caused. Here wave is moving like this, side C, depolarity is caused. There is a site D, depolarity is caused. Here this wave get be transferred from one region to that, or one side to that another side. Here depolarization is caused, here repolarization is caused. This wave is moving here, here depolarization is caused, here repolarization is caused, here hyperpolarization is caused. There are some events are there, they are depolarization, there is the depolarization, repolarization, hyperpolarization. Hyperpolarization. During depolarity, changes occurs minus 70 to plus 45 millivolts, 125 changed. During repolarization, plus 45 to again changed into minus 70. Reverse is there, and repolarity. What is the reason for causing the repolarity and the time? Plus 45 converted into minus 70. Reason, due to the more, that is a effluxivity of potassium ions. Here, during repolarization, I draw here a repolarization condition. During repolarization condition, there is a potassium gated channels are the specific channels present on the membrane. Their gate is open, only one gate. Effluxivity is caused. Due to the effluxivity of potassium ions, charges becomes changed from plus 45 to minus 70. Question is asked maybe like this. During repolarization inside the axoplasm, what is the value will come? Minus 70. How it is come? How it is occurs? Due to the effluxivity of potassium ions by the opening of potassium voltage gate channel. During hyperpolarization, potassium voltage gate channels remains open. More effluxivity of potassium ions are seen. Their value becomes more negative from minus 70 to minus 90. During hyperpolarization, their value becomes minus 70 to minus 90, which means more potassium ions are effluxed due to the efflux through the potassium leakage channels. Potassium leakage channels are opened at which situations? Repolarity and hyperpolarity. Potassium voltage gate channels are opened during repolarization and hyperpolarization. For that, potassium voltage gate channels, closing is difficult and opening is difficult. The channels are called lazy gate channels. Lazy gate channels. Whereas sodium voltage gate channels both are opened during depolarity state. This is very, very important. Sodium voltage gate channels are opened, both are at depolarization state. Potassium leakage channels open during repolarization and hyperpolarization. So these are the different that are the mechanisms which are seen during conduction of action potential, and there are the different headings you observe. That is the polarity, depolarity, repolarity, hyperpolarity. More becomes negative, hyperpolarity. Less become negative, depolarity. Resting state membrane potential at which axoplasm containing minus 70 MV millivolt, depolarity plus 45 MV millivolt, repolarity minus 70 MV millivolt, hyperpolarity minus 90 MV millivolt. So this is about that action potential. In a second video, I explains about the synapses concern, what is the way that action potential get be traveled through the synapses is very, very important. Thank you very much. All the best, my dear students. Please subscribe my channel. All the best.